All right, everybody, welcome. We are now live. We are going to give. I'm going to give about one more minute to allow more people to potentially join us. Grab a cup of coffee or tea or whatever they drink during lunchtime, at least here in the Eastern time, and uh, and then we'll start. Where we go? Theron, Lefis. Okay. Oh, it's hot. Farron, we might get along the way some, if we do get any questions or comments from people watching us from on social, I'll field those questions to you, okay, throughout the talk.
Sounds good.
I'll do one last thing. I'll just notify the public community on Discord that we are starting in 1 minute, and then we'll get started. All right. You this. All right. Cool. All right, folks, let's get started. We already have more than a dozen attendees or viewers on our social, so it's a good opportunity to get started
Great.
since we have a lot to showcase today. So, everybody, welcome to the Plotly Hangout of June. We started this about a year ago. These hangouts are a space where you can meet and interact with data scientists and data analysts merged in the world of data visualization, Plotly, and Dash. Now, you're going to often hear from our guest speakers about their professional experience, the journey that brought them to where we are today, as well as the lessons that they learned along the way. Your participation in the Hangout is highly encouraged, right? I'll be talking to Faron. He'll be showcasing many things in the climate science world. But if you have any questions, comments, really things you're not sure about and you want to learn more about, just feel free to either send us a message via the social media platform that you're using, or here, if you are live with us, you can just use the private chat and we'll see your questions. If you're more of a chat person, definitely use the private chat. If you just want to unmute yourself and or come on screen and ask the question, let me know and I'll add you to the stage. All right. A reminder, this session is being recorded. It's being live. And to get started, I want to introduce you to Faron Anslow. Faron, thank you for joining us.
Thanks for having me, Adam. I'm glad to be here.
A little bit about Faron. Faron grew up in Portland, Oregon, and he gained an interest in earth science at a very young age. He then earned degrees in chemistry, geography, and geology with a minor in atmospheric science. And he studied glaciers and ice sheets, past, present, and future. And his work was helping humanity in general better understand how extreme weather events are linked to climate change. And currently, he's helping to disseminate projections of future sea levels for Canada coastlines. Now, during the Hangout, Faron will show us a few things. We're going to talk about Plotly as a tool used for data exploration. We'll talk about Plotly and Dash to build an app for monitoring snow in British Columbia. It's actually a pretty cool app. I saw that. And then self-serve data exploration and figure styling for Canadian sea level projections. All right, so we have a lot that we're going to learn about today. A lot of this is also new to me, so I'm pretty excited about this hangout as well. Faron, to get started, can you tell us just a little bit about yourself?
Yeah, I guess I've got a passion for natural science that I've had from a very young age. So I basically started out in chemistry, and then as I realized that being in chemistry meant being in a lab, or that's what I thought anyway. I transitioned over to earth science because at first it was just because I really like to do field work. I was interested in mountains and glaciers and climbing and that kind of stuff, and saw glaciology as a way to kind of bring my desire to be outside together with my interest in science. And then all along, I've been really interested in computers and programming from a very young age as well. Never was a great programmer. I'm in that group of scientists that doesn't have any training in programming, but programs a lot. So tools like Plotly that are easy to learn and easy to grasp are great for people like me. Yeah, nowadays
You just learned, you just learned programming as you did your studies.
Yeah, I started out on a really old computer called a K-Pro, which ran like a pre-Microsoft DOS,
Okay.
programming in BASIC, and then yeah, through my studies, various scripting languages like MATLAB, and did spend a lot of time programming Fortran, which is commonly used in earth sciences. Um, I hate the idea of having to go back to that. It's kind of like COBOL. It's one of those old languages that
Yeah.
still gets used a lot.
Yeah.
Yeah.
And so you said you learned, was that your graduate degree, glaciers?
Yeah, my master's degree was in geography, and I studied kind of how weather interacts with a glacier to make it melt. It's called surface energy balance modeling.
Okay.
So yeah, just looking at the kind of how the energy goes into the glacier surface and causes the snow and ice to melt away, or get cold and accumulate.
And then after those studies,
Yeah, then I did a postdoctoral stint in Vancouver. That's how I got up to Canada for the last time, where I still am today. And that work, we tried to simulate the loss of all the glaciers in BC with climate change. So just looking at all the snow and ice that's in the province here and how it's going to change over the next 100 years. Using climate projections, so computer models of how the temperature and snow and rainfall is going to change over time. And
nice.
yeah, it was a little bit of a sad story. We're going to lose quite a lot of the ice here in British Columbia, but not all of it. But that's where we are.
What made you want to stay in beautiful Canada after the move? Were there just more glaciers there?
yeah, that's part of it. I'd become an avid surfer when I was doing my PhD in Oregon,
Okay.
and I moved to Vancouver and then realized that the surfing to be done was here on Vancouver Island. And so even though I lived in Vancouver, this beautiful city with mountains and glaciers and snow and skiing, I was always on the ferry coming over to Vancouver Island to go surfing. So I realized I should probably move over here if I'm going to keep doing that.
How long have you lived on Vancouver Island?
I moved here in 2011,
Okay.
so
Almost
14 years.
15, 14, 15 years.
Yeah, yeah.
And now you're working for.
I work for the Geological Survey of Canada, which is a department of Natural Resources Canada. Yeah, I'm currently doing just kind of a medium-term contract, but likely to renew that contract for a longer term.
And you're in. First of all, how did you find your way to that position?
Through contacts that I had with a previous job. So I worked for about 11 years as a lead for climate analysis and monitoring for British Columbia. So in that role, I was kind of looking at weather and climate data, and then monitoring for extreme weather events. That included we had a big heat wave 4 years ago, and monitoring that and doing some research looking at how those extreme events were linked to climate change. Also did some work with wildfire looking at some really, what
Oh, wow.
back then were really bad wildfire seasons. They've been surpassed since then, unfortunately, but trying to link those to climate change as well.
So you've had a nice amount of projects and things that you took on. What would you say is one that stood out to you that you really enjoyed? I'm sure you enjoyed all of them, but one that really you learned a lot and you remember very well.
Um, I guess two stand out really well. One was is a project I was just helping out on, but I got to spend time up in the Canadian Arctic.
Oh
I
wow.
did as part of a 3 week expedition up there to measure snow and basically prepare for an ice core that was going to be drilled up on Ellesmere Island. So that stands out just for the physical beauty of being up in the Arctic in the spring and snowmobiling around with my supervisor. And then that study of the heat wave that we had here stands out both because it was extremely hot. We knew it was breaking all kinds of records as it was happening, and so I was sitting in my unair conditioned house, and here in Victoria it only got up to in Fahrenheit maybe high 90s, in centigrade it
Okay.
just about touched 40. So not super hot compared to the rest of the world, but really hot for us.
Yeah.
And I was sitting in my house, just baking, just sitting there in shorts, just dousing myself with water as I was analyzing data as it was coming in. So it was this like really about as extreme of office work as someone can do.
Yeah.
Felt like a critical mission at the time.
A nice
um,
coincidence.
yeah, and the paper is with an international group called World Weather Attribution, looking at links to climate change and extreme weather events, and it got a lot of international traction, and I spent a lot of
Okay.
time talking about it. So, yeah.
All right. All right, Farron. Well, I remember the a couple of weeks ago when we met, you showed me some pretty cool data apps that you built with Plotly and Dash. I know that you wanted to give us some context a little bit before you actually start presenting. Would you like to do that?
Yeah, so actually I've got the app on the share, but maybe I'll switch. I just have a few tabs of kind
Okay.
of background information, so I'll stop sharing and switch to another tab if that's okay.
Yeah.
All
Okay.
right, so
One
do you
second.
see
One
see
second.
a
Let
pretty
me
old
add.
looking diagram of um, yeah. So
Okay.
the first app, I started to develop it both out of interest uh, that I have regarding weather and especially snow in British Columbia. I like to ski, and every year we're kind of wondering if this year is going to be a good snow year or not. Um, and a lot of that around here has to do with something called El Nino, or the El Nino Southern Oscillation. I think most people have heard about it by now, but it's a phenomenon in the tropics that influences weather worldwide, but it has really strong impacts on Western North America. Um, and basically, there's two phases. There's an El Nino phase, which is at the top of this figure, and what it winds up bringing is typically warm conditions to British Columbia, and often a little bit drier than normal. And then you have years where it's the opposite phase, the La Nina, which is shown down below, and it's typically wetter and quite a bit colder. Um,
Farron, when you say bring in warm conditions versus low conditions, are we talking about warm air or also combined with warm waters in the ocean?
yeah, it's warm water, kind of right along the coast.
Okay.
But the reason you get that warm water is during an El Nino, yet the the air circulates more from the south, and so it pushes warm water up against the coast, and
Mm,
it also brings warm air from the south uh,
nice.
to BC. and La Nina the opposite. You have cold air coming down from Alaska or from the Canadian Arctic, and often combining with wetter conditions to bring lots of snow.
And these, if I remember correctly, regularly happen once every couple of years.
Yeah, that's right. Yeah, every 2 to 3 years, but it's not a oscillation like a pendulum. They can, we'll get multiple La Ninas back to back. You can get multiple
Okay.
El Ninos back to back. But yeah, the 3 to 7 years is the kind of the changeover period. I'm going to switch, just show one more tab, and then I'll get to the app here. Sorry about that.
Folks, this is a good time to remind everybody watching us online or here with us. Feel free to ask any questions, beginner questions. Uh, if you don't know anything about climate change or El Nino, what Theron is showcasing, please feel free. I'd love to have Theron answer any community questions you might have. Hi, Farron. We now see the map of the North America.
Okay, great. Yeah, I've switched to sharing the whole Chrome browser, so shouldn't have to switch back and forth. Yeah, so one of the things you expect with colder and wetter conditions is more snow in the wintertime. And I forgot to mention that winter is when El Nino and La Nina have the greatest impacts in North America. And so that's what this map is showing, just how much more or less snowy it is. This is from a weather model, but how much more or less snowy it is over British Columbia and all of North America during a La Nina winter. So basically, you see in BC, for the most part, it's quite a lot snowier on average with a La Nina. And so what I wanted to do with the app is explore looking at the actual data on the ground, measuring the snowfall, combined with the data telling us how strong an El Nino or La Nina, or how weak an El Nino or La Nina we have is, and how that's relating to the snowfall. So I basically took all the historical data of what's called snow water equivalent. So that's basically measured by these instruments they're basically a big whoopee cushion filled with antifreeze on the ground that measures the weight of snow sitting on top of the whoopee cushion, and tells you how much snowpack there is. So the more snow there is, the heavier it is, and the instrument measures that. And in the app, the interactivity is filtering that data based on how strong or weak El Nino or La Nina is. So in the app, I've just got an introductory modal, little disclaimer. So this data is publicly available data from the BC River Forecast Center, British Columbia River Forecast Center. All right, so the app here, there's really three components. There's the map on the left here that shows you a map of British Columbia. It starts out with all the locations where there's a snow pillow. That's the name of these snow measuring devices, snow pillow station. And I've styled the hover to show you the name, the ID. Elevation is really important, especially as we have our changing climate. What we're likely to see in the future is you start to lose snow in the winter at the lower elevations, but the higher elevations will stay about the same until they reach the critical temperature. And in some cases, you may even get a little bit more snow at higher elevations with the warmer, wetter climate. Down below the map, we have some controls on the map, what's shown in the map. So we can filter by, I just have a 20 years or more filter. So if you want to look at all the data that includes short records, you can unclick that, and you see a nice population of stations. they select for areas where there's snow. So those are the higher elevations or the more northern elevations in BC. They also select for areas that are more or less populated. So there's this big area up in the northern British Columbia where there's pretty big mountains, lots of glaciers. But there's not a lot of snow measuring going on up there. We can look at active or inactive stations. So for the analysis I want to do, I want stations that have the current year, so active stations. I like long records because then you can start to say things about relationships between what you're looking at and or the correlations between things. And I have another option to plot the anomaly. So how much snowier or the station is than average. So right now it's kind of a bad time of year to show this app off because it's the end of the snow season. So most stations don't have any snow anymore.
This is fair, and this is live. This is getting the data from the last day or two, or how far back is it going?
Yeah, it's within 2 days, so it updates every day. And then the main thing that we have plotted here is the evolution of snow over the season. And so the x-axis here is time, but it's not assigned a year. It's just the calendar day, and then the y-axis is the amount of snow. And when you initially load the app, you have in black the current year. And so if we hover over this, it shows that grab data. I guess we're a bit behind on this station. Grab data on the 20th. Some stations report less frequently.
That's very little snow if the black is under everything.
Yeah, so this year was actually a La Nina year, and so we expected to get more snow than average. It was a very, very weak La Nina. It didn't evolve into a full-blown event, but yeah, so we're below these averages. And what these averages are, so when you first load the app goes and grabs the historical record of the strength of El Nino and La Nina, and it sets a filtering range. So that's this slider at the bottom, based on that strength. And so it's on load. It's noted that we have a La Nina year, and so it set a filtering range that covers from the strongest La Ninas to what I'm calling neutral, which is kind of the bottom end of what you'd classify as an event. And what this slider does, it changes this blue trace. So this blue trace takes all of the years that have that strength of La Nina or El Nino. It takes a median and a range, so one standard deviation range for each day of the year for all of those records. So because this is Plotly, you can just click on a legend item to get rid of a trace, which is a really nice feature. And so what we have left now is looking at all of the data. So this is the entire record, the median and the range for each day of the year. So on average at this location, which is Squamish near Vancouver, you get the most snow kind of in the middle of April. The snow goes away by early July. The snow starts kind of late October. And yeah, this range, it covers, from 1,200 millimeters up to 1,800 millimeters.
And this is, Faron, this is snow accumulation, right?
That's right. Yeah. So it's adding up over the year, and then as it melts, basically the weight of the snow on the ground increases with more snow and decreases as the snow melts away. So yeah, that's correct.
So from what can I use a slider below to, because this black line at the very bottom you said is this year's 2025, which we see compared to average snow accumulation over the years from when? From 1996?
Yeah, I should print out the whole record or what the record is. Yeah, so 1996 is the earliest year. So all these years on the bottom are years that were a La Nina. If we change the slider to incorporate the whole range, then we have all of the years in the record. So the record goes back to 1990 to
1990.
2025.
So I was going to ask her, is there a way to, um, because this year was supposedly a La Nina event. Is there a way
Mhm.
to move this? How would I move the slider so I only see averages of La Nina events and nothing, not Nino, not El Nino?
Yeah, so you can grab the slider at the bottom, um, and the top end on the left it's the La Nina end, and if you grab the other side of the slider, it's a range slider, and bring it back to neutral or moderate.
Okay.
Um, and the closer you move these sliders together, the narrower the range, and eventually you start to lose years. The current year isn't filtered; it's always shown.
Okay.
But if we go from neutral to extreme La Nina, that covers all the years that were a La Nina. And then the blue average is the composite from all those years.
And if I wanted to compare, if you leave it there, the slider, and I wanted to compare 2025, which is there, to let's say 2020, 2024 is not on there, so like 2023.
Yeah, so you can just click the line.
Nice.
Yeah, and if you want to just look at a big spaghetti plot, you can double click to turn those on and off.
Wow.
Yeah, so it's a really nice. So if we look at the whole spaghetti plot, there's this really famous year here in uh, the Pacific Northwest, Western U.S., where 1999, where we had this just unbelievable snowfall year.
Were
And
you there in 1999 when all that snow fell?
I was in Oregon, but I remember our little mountains that I used to cross over to go rock climbing. There are places that usually have snow, but it never has avalanches. There
Yeah.
is avalanches happening every week, closing a highway that no
Wow.
one had ever even thought would happen. So it was a really, really amazing year.
Would you say this is something we should be when you look at this data compared
Mhm.
to this year and the last 5 years, does this concern you? Like, what kind of thoughts go through your head?
Um, yeah, so the trends in snow are they're a little bit weaker in British Columbia with our changing climate, but at lower elevations, we are seeing less snow as the years go on and it gets warmer and warmer. If you go down into Washington and Oregon and California, the trends are much stronger. I haven't. It's on my list of to do with this app is to put in ways of looking at those trends. So maybe introducing another tab. Um, I am calculating in the background some of the metrics like uh, what time of year does the peak snow happen? What time of year does the snow go away? How high is the peak snow? How high is the average snow? And then looking at those over time for each station. But I haven't implemented that yet.
Nice. This also, I'm assuming, calculates by default like snow melt as well, right?
Yeah, you can look at how fast the snow is melting by the steepness of that line in the summertime.
Yeah.
And yeah, that's another thing I've been thinking about is um, the steepness of that line is directly related to whether or not we get floods in the springtime. Here in British Columbia, the high water events on our rivers tend to happen when you have a lot of snow melt. And so a La Nina year with a lot of snow in which you get a really hot period actually leads to some of the worst floods that BC typically sees. Although that's also changing with climate change. As things warm up, rain starts to be more important for flooding. But still, right now it's snow melt.
How long
Um,
did it take you to build this app?
I've been poking away at it for a little while. I built it before I started using AI.
Okay.
So kind of bones of it took me, maybe a month, but that was really only working 1 or 2 hours a day on it, so not really intensive. And then, like anything, you can refine forever. So I'm still in the process of refinement with this app.
Very nice. This is so helpful for people, especially for people, well, climate scientists in general, but for North America, but for people living in British Columbia. Even if you're not a climate scientist, like you ski or you do winter sports, this could be very helpful.
Yeah, I use it, and I've got friends using it when this time of year comes around and you want to get up into the mountains, but you're worried about snow on the trails. So here on Vancouver Island, if we look at all of the stations, so there's a really nice. This Heather Mountain is a really nice hike. And we can see that the snow is gone as of the middle of the month.
Yeah.
So this time of year, you could head up there and go for a hike.
Nice.
Yeah.
Did you? I'm sorry if I missed this, Farron, but did you also already go over the analysis tab?
I did not. These are just kind of documentation tabs.
Oh, okay.
So they talk about how to use it and how I analyze things. I think eventually I'll put some of that climate change analysis into a tab and have a bit more interactivity there. Yeah.
Sweet. Esther said she really likes the layout and the colors that match.
That's great. Yeah, I from participating in Figure Fridays and getting feedback from the community just on some of those figures, I was inspired to go in and clean up the aesthetics of this app. So yeah, I really want to thank the Plotly community and the Figure Friday people for all their inspiring apps. It's some really amazing stuff that they do.
Of course. Thank you for mentioning us, Farron. Figure Friday, for those who are watching us, is that Farron mentioned, is an initiative that happens every week where we release a new data set that the community works on, builds graphs, build dash apps on top of. And then the following Friday, Figure Friday session, we meet to talk about all the graphs and apps and then share feedback with each other. So it's a great learning opportunity and a great opportunity to meet other community members in the world of data analysis, Plotly and Dash. All right, Farron. So we have this. Is there anything else that you wanted to mention in this app?
I think the only thing I'd add is, kind of to get to the question I was trying to answer is whether or not, or trying to look at the data and see how El Nino and La Nina affect the station. It's really just with playing around with that slider. I think there's room to have some summary data presented that kind of makes it more concise, especially across all of the stations. If you go to this location, Blackwall, which is southern British Columbia on the border with Washington and the U.S. So right now I have the El Nino selected. The color changes. El Nino tends to be warm, so I've got warm colors. You can see on average for an El Nino at this station, you have quite a bit less snow. Snow goes away earlier. Interestingly, it peaks later. Whether or not that's significant, I don't know yet. But and it also interestingly, you have less variability in an El Nino year if we compare that to a La Nina.
The range is bigger.
Yeah, you get a bigger range. Here you get a much later peak in the snow. You get a bit later loss of snow, and then the highest years are much higher.
And one of my colleagues was saying, Rob, that he went skiing in that area around 2 weeks ago. But we can't see like how the snow was 2 weeks ago, right? This is only 2 days, you said.
You'd have to feel it out with the current year line. Yeah, it must have been some spring skiing. There's definitely some snow around.
Wait 1 second. Let me add 1 second, Rob. Rob, I just added you to stage. We can hear you now.
Yeah, it was serious spring skiing. We did Mount Cheam, which is just in Chilliwack. Still snow.
Are you there? Nope.
Yeah. Faron, can you hear us?
Yeah, I can hear you. Yep.
Rob, can you just repeat that?
Sure. Yeah, we did Mount Chima and Chilliwack, and there's still snow if you get those north aspects and look in the right place. But it was serious spring skiing conditions.
lots of sun cups.
Yeah. A lot of sticky pollen all over the snow.
Oh yeah. Yeah, it's always fun when you're going down at the end of the day and your skis start to stick and you almost go head over heels over your tips.
So, by Faron, how would people like Rob and other skiers potentially use this app?
Yeah, so Chiam would be here or near the station. You'd have to find the station nearest you. So that's an interesting point of interactivity that that you could easily do in Dash and Plotly is you could enter someone's current location and use a kind of a location API to find the distance to the nearest station. But I know where he's talking about, I believe, and so here's the Chilliwack River. And he brings up a good point that, snow really depends on what direction you're facing. So south-facing slopes in the northern hemisphere melt out much more quickly than north-facing slopes. So even though and they tend to put snow pillows on really flat locations, so they're going to melt out before the northern aspects. So this station, it's also at a lower elevation. So at 1,600 meters, it lost its snow just over a week ago, or under a week ago. So not too long ago, but definitely snow in the higher elevations on other aspects. Yeah, to answer your question, I probably just look at the current curve. So click off of these elements in the legend there, and just use a hover to try to find, assume it's not always true, but they tend to be up-to-date data and look at the current data and see where you're at in terms of snow. I wouldn't recommend using this for avalanche concerns. There's really good resources for looking at avalanche danger. That you can definitely pick out the places where there's rapid accumulation, and those might be times to be careful in the backcountry if you're into backcountry skiing. They'd also be good times to go inbounds and try to catch some of that fresh snow.
Nice, cool. Rob, do you have any questions about this or comments before we move on to the next app?
I'm enthusiastic to use it. I'm a bit of a turns all year type, and so I are always looking for places to ski in the summer. And using this as an indicator, especially this time of year, and then plus the knowledge of like what is glacier and what is northern facing slopes, this is an awesome tool. I'll be sharing it.
Cool. Yeah, if you zoom into this is the I had Mapbox layers in the background, but now it's switched to what is it?
Open Libre.
Map
Libre. Yeah, that's right. If you zoom right in, it actually shows. I don't think it shows contours, but some trails will show up. So yeah, you can pick out the glaciers and all that stuff. Another element I've thought about adding is you can think about how snowy it is compared to normal by looking up and down. But you can also see if you're kind of early or late compared to normal by looking at the distance along the x-axis. So in this year, say we cross at 500 millimeters, that happened on June 7th, whereas on average, that's maybe something like hovering over the wrong line, but the 22nd. So this year things were melting out 2 weeks earlier than is typical. That might be another interesting thing for people to look at, especially when you're gearing up for that ski season opening and you're wondering if you're early or late.
Or same with like future quote unquote, not prediction, but estimates. If we know that next year, 2026, the climate scientists are expecting El Nino, we can just look at the slider and just choose a menu and see how much snow accumulation we might expect.
That's a great idea. There's also some seasonal forecasting for models that you can grab the data and actually look at how much, quantitatively, how much wetter or drier or cooler or hotter it's supposed to be. So I bet combining those things, you can make a better than nothing model of what you think is going to happen, and throw some error bars on it and caveats, but it'd be a fun thing to look at for sure. And then later on, you could go back and look at what your predictions were and what actually happened, and see how it all played out.
Awesome.
Another thing I'd like to do is just extend this down into the States. All that similar data exists in the US, and at the moment anyway, it's still freely available, so it'd be fun to expand this app out.
Cool. All right, Faron. We do have about 17 minutes left, so maybe we can jump to the other app.
All right. So I'll just give a quick intro slide. So this is jumping over to the issue of sea level rise. And this is a very complicated slide, so I apologize. But the point here is global sea level rise. It's not just adding water to a bathtub. You actually get different amounts of sea level rise relative to land, depending on where you are on the globe, for a large variety of reasons. But the bigger ones are how much the land is lifting up or subsiding, and then the other kind of big issue is just the ocean dynamics. So how the winds are pushing the water around on average, how strong the storms are, the ocean currents, things like that. And so this is important when we're looking into the future and we're looking to plan for sea level rise in Canada. So just switching right over to the app here. So Canada, in 20,000 years ago, we had a huge ice sheet sitting on most of the continent. And that ice sheet is pretty much entirely gone. There's some little fragments of it left in the Arctic, but the imprint of that ice sheet is still around. The land is slowly lifting back up from where it got depressed from having that ice sheet sitting on top of the continent. Basically, the Earth's mantle was displaced by that crust being pushed down, and that mantle material has to slowly fill back in and push the land back up.
How thick were the ice sheets? What was the estimate?
They're at least 3 kilometers. I know it's more than that, but I don't want to give a bad number. But
yeah, well, it depends on the latitude, probably. But 3 kilometers of ice sheet—that's a lot of weight on the Earth.
Yeah, it was enough ice to just lower sea level by almost 70 meters. So really significant amount of water sitting on land.
Yeah.
And so loading up the app here, the first page, it's just looking at the dots are cities in Canada, and the colors are the amount of relative sea level rise for a year that's set by a slider at the bottom here. So I've chosen the subtitle, year 2070, and then this code underneath the year, it's the projection, the climate projection that we're using. So climate scientists use various what they call scenarios, where they kind of model out what they think society is going to do to respond to climate change, if anything, and set out some scenarios that depict how much greenhouse gas is going to be in the atmosphere over time. And then they give that information to the climate modelers, and they put that in the models and assess how the Earth's system is going to change with that amount of greenhouse gas change. It also includes land cover and a lot of other things. So we play with this slider here. So going back to the scenario, this is kind of what's commonly thought to be what's going to happen. It's kind of a mid-range scenario. If we move the slider up to 2150, so it's kind of the long end, you see in red places where there's sea level rise. And then in blue, we have places where there's sea level fall. So a lot of these areas are where that ice sheet was, and they're rebounding faster than the ocean levels are rising. And so the sea level is not outpacing how much the land is lifting out of the sea. If we go to zoom in on BC, let's use the interactivity here. So if we pick British Columbia, it zooms into the area of British Columbia that has ocean, so it's not the whole province. And we can look, even in BC, there's quite a bit of variability. This data in the background, it has a very detailed model of the land motion in Canada. And so this kind of the reason this data exists is kind of customize the climate projections for sea level rise based on that very detailed model of how Canada's land is moving. So if we kind of zoom into this eastern Vancouver Island area, you see less sea level rise. And that's because that's an area where there's a bit of probably tectonic uplift, so due to the motion of the plates. And also the loss of glaciers in the Coast Mountains of BC. So it causes the land to spring back, similar to how the land is still rising from where the ice sheet was Canada-wide. Even when you lose relatively small glaciers, you get a pretty sharp uplift due to the elastic rebound of the land. So this is just kind of an overview. You can.
Would there be any other reason where it'll be less red, where it'll be let's say, technically speaking, the ocean level doesn't rise as much, beyond the fact that the Earth crust is like springing back because of the heavy ice sheets that during the Ice Age? Would there be any other reason why it's slowing down and it's not the ocean is not catching up? It could be like a bay area or a certain part of the land where it's different.
Yeah. So you have the tectonic effect. So in places where the two plates are causing stress on each other, and that can cause the land to rise up or subside. Another really big player here is we go up to Ellesmere Island, this little, not really a town, but this location, Eureka, Nunavut. What's happening here is the projection is that as the Greenland ice sheet melts, so that the ice on land has gravity, and it actually attracts the ocean towards itself. It's kind of bizarre. So if you have a big mass of ice sitting on a continent, the ocean isn't flat at the shoreline. It actually mounds up as you approach the continent. And as the ice melts away, that mound disappears. And so what's projected here is the loss of ice in Greenland, and also the loss of, this is the ice cap I went and studied on Ellesmere Island. The loss of that ice is going to cause a gravitational and a rebound effect to happen. So some of these areas in Canada where you're losing land ice and you're under less influence of the gravitational pull of Greenland, causes the sea level rise to be, the sea level change to be quite negative.
That would be something only temporarily, and then it will just like the ocean will slowly find its way back, or it's a permanent change.
It's a permanent change, yeah. So the ocean is not flat because the ice sheet is there,
Okay.
and when the ice sheet goes away, it'll flatten out. The ocean's not flat for a lot of reasons, but that's one of them. So yeah, so places like this will see sea level fall, and except in really extreme cases of Antarctic ice loss, um, it'll stay low. Or Greenland ice loss. There's about 8 meters of sea level in Greenland when that eventually goes. But
Wow.
yeah.
And what is that? You were moving that, you were changing that drop down values. What does that do?
Yeah. So we have SSP is basically the emissions scenario. The larger the number on the tail there, the more extreme the case. So 585. So it's the emissions pathway version 5, and the kind of concluding number there, 8. This is actually 8.5. That's the radiative forcing at the end of the scenario at 2100. So 8.5 watts per square meter.
But Farron, for those who are not in climate science, what does that mean? Is this correlation with the amount of carbon in the air and the bigger greenhouse effect?
Yeah, exactly. So that's CO2. It's methane. It's the compounds of nitrogen, and then also the counterbalancing of aerosols in the air and dust and things like that help cool. So all those things are included. Over here, you can, this selector isn't tied to the map, which is maybe not the best design, but starting out, you can pick towns based on which province or territory is selected. So if you just go to British Columbia, then your drop down here is listed by or restricted to British Columbia cities. But if we go Canada-wide, let's just work with Prince Rupert and Vancouver, so two cities kind of on the north and south coast of British Columbia. We can switch over to these tabs. We'll start with the progression plot. And this is just how sea level is projected to change over time, with the range being that's by the kind of the international committee, the kind of the most likely scenario within that emission or that scenario. The reason this app exists is one of the things I do here is I make figures for various reports, and the code that I inherited was in another plotting library, and every time someone wanted to change something, which is usually a font related change, I had to go into the code and I had to find the number and I had to change it. And I was like, well, in Plotly Dash, you can just do all this stuff with callbacks. And so the whole idea here is to be able to do that stuff without having to dig into the code. I can just have this app sitting live it's internal to our servers. And then I can change, the font size of the title, or the legend.
Nice.
If I want the legend on the bottom, I can put it here. So if we go back here and we pick more cities, it stacks them up. And then the thing I really wanted to get at and that I've been working at is, we tend to, in reporting, use PDFs or other vector graphics, and through the Kaleido library, you can extract figures as a PDF. And so I've set this up so you can enter a file name and hit download, and it'll give you a PDF.
Nice.
Oh, well, that showed up in a different window, but it's a nice looking PDF. I worked at it to make it kind of what you see is what you get in terms of the figure. You can also just use the mode bar buttons from Plotly, and I've set these to download a high resolution SVG. Let's see if this one, that's going to open in Edge. Sorry, but they look great, which is the point. So this way, if I get an email and someone says, "Oh, I want to know what's going to happen in Loch Wallams, BC," then I can go Loch Wallams, which is a little First Nations community in the northern coast. I can pull it up. I can play around with these stylers. We can change, if the ranges are shown. There's something called this extreme projection at sea level called the Van de Waal high end. So that's kind of the highest worst case scenario. We can limit it to 2100. It's basically do all the things in this app that I was having to muck around in code to do with another plotting library. So it wasn't super hard to translate from that library into Plotly. So
it's amazing what you've been able to do with Plotly and Dash here. It's so useful for you. You don't have to go back. It saves you so much time. Other people can interact with it. Well, this is Eternal Server, but the other one people can interact with.
Yeah, there's kind of a sneaky reason I made this is so when I go on vacation, I can just hand this website to my supervisor. So instead of coming back to a bunch of emails, with figure requests, they can make the figures themselves and
download the PDF.
Just download the PDF and put it into a report.
Really cool.
It's wonderful. Yeah, it's really, really great tool.
All right, Faron. We do have, unfortunately, out of time. I have a few more, just under a minute. What I do like to end these hangouts is with one concrete suggestion or advice for our viewers. So, what advice would you like to share with our audience before we end here?
I would say, first of all, just start exploring with the data that you have. I don't think I've found any limitations to what you can do in a Plotly Dash app. In the realm of data science that I'm doing. Whether or not you can solve world peace is another question, but I'd say start exploring right away. I actually didn't know any Python, or very little Python, before I started learning Plotly and Dash. I use Plotly and Dash as a way to learn Python, or at least kind of get into it. So don't be intimidated by learning a new language to be able to do it. And then, so I think the main thing is just be courageous and play, have fun with it. It's a really nice way to explore your data. When Adam and I first chatted, I was telling him about another thing I was working on. I just wanted something I wanted to see in my data, that if you plot a traditional figure in detail, that's a static figure, I couldn't really get out of it. It was only by making a dynamic Plotly figure that you can zoom into and get hover information from, that helped me just understand a particular data set, and that you can only do it. It was super easy to start to explore it by just use Plotly Express or one of the simpler versions, to just get a figure up and start to mess with it, and then that will lead you down the rabbit hole of making it as beautiful as you want to make it.
Yeah.
That's another really nice thing about the library, is just the look and feel of the figures is really nice by default.
Yeah. Cool. Faron, thank you so much for joining us. Before we end, I just wanted to remind the community of our Figure Friday happening this Friday. We'll have a Figure Friday session. We'll release a data set for next week that we can work on together. So please join us. We have our first Plotly meetup in real life in Raleigh, North Carolina, and in Toronto tonight. We have the one in New York City in about 3 weeks. And we will have our next Plotly Hangout, as always, the last Wednesday of the month in July. So just join our forum at community.plotly.com, or just Google Plotly Forum and open an account there, and you'll get all the notifications of everything that is happening, in addition to a Plotly events calendar that we are going to be publishing in a few days. Thank you, everybody, for joining us. Faron, thank you so much again, and
Thanks, Adam.
I'll talk to you later.
All right, take care.
Bye-bye.